So far, we've seen the definition of a rational function as well as how to simplify rational function. Our next goal is to learn how to do operations with them. The first operation is multiplying them. It's very straightforward here. We express them in a fully factored form and we cancel the common terms. So it's very much similar to simplifying rational expressions. For example, here, first step, you fully factor stuff. I skipped over the steps for factoring, but you can see them right here. It's the same idea of factoring a trinomial by splitting the middle term. And you get the solution. Similarly here, now you want to be aware of some of these, like this is the difference of squares, so it factors directly into x minus 3 and x plus 3. Dividing rational expressions is the same as multiplication. All you have to recall is that division is the inverse of multiplication. So if you have a fraction p over q divided by r over s, you can rewrite it as p over q times s over r, meaning you flip the second fraction. For example, x over 7 divided by 6 over 7 becomes x over 7 times 7 over 6, which is x over 6. Example, here you can factor this using the difference of squares. Becomes 2x minus 5 and 2x plus 5, which gets cancelled, leaving you with 14 times 2x minus 5. You can try the second example and verify that you get this as your answer. Now the next operation is slightly complicated, adding, subtracting rational expressions, functions. Now since the best analogy that we started with for rational expression is fraction, we start by looking at addition and subtraction of fractions. Now 1/3 plus 2/9, the idea here is that we make a common denominator. Why? If you use a visual cue, 1/3 is 1 out of 3 and 2/9 is 2 out of 9. Now you can't really combine them unless you make the total the same. So to make the total the same, I can rewrite 1/3 as 3/9, and now I have 3 out of 9 blocks. So now when I combine, I end up with 5 purple blocks out of 9 black blocks. So the idea is that we ask the question, what do we need to multiply 3 by to make it 9? In this case, we need to multiply 3 by 3 to make it 9, but we can't just multiply the denominator by 3. We have to multiply the numerator by 3 as well, because 3 over 3 is 1, which means I'm multiplying it by 1 and its value is not changed. Now, how does it translate to rational expressions? This comes down to finding what is called the lowest common denominator. The process of finding the lowest common denominator can be broken down. It's similar to our method of greatest common factor, which means we find it for the numbers first and then for the expression. For example, finding LCD of 6x squared and 6x squared and 9x. And LCM of 6 and 9 is 18 because it's the lowest number that is a multiple of 6 and 9. Another way to find it is you start with the numbers you're trying to find an LCM for, then see does 2 divide both of them? It doesn't. Does 3 divide? Yes. So you divide by 3 and then you type out the quotients here. Now at 2 and 3 you can stop because there is no number that divides both 2 and 3. And then your LCM is just going to be the product of these. So you get 3 times 2 times 3, which is 18. Now when it comes to the variable part, it's really easy. It's just the highest power. So highest power between x squared and x is x squared. And then you can complete this. So you know that your, therefore, LCD is 18x squared. To get an 18x squared, I need to multiply, there should be 3, 6x squared by 3, and so the numerator by 3, and 9x by 2x, and the denominator by 2x. So this is incorrect. It should be 21 plus 4x over 18x squared. Let's look at a different example. Again, the first step for finding LCD is also to factor the denominator completely. In this case, 7x squared plus 8x is 7x times x plus 4. And the second term using a squared plus 2 times ab plus b squared is a plus b whole squared. So now, if you compare for the numbers, you get 7. The highest power of x is x. The highest power of x plus 4 is x plus 4 times x plus 4. And so the LCD becomes 7x times x plus 4 squared. And multiply all the factors. Example. Now here, the denominator is x minus 3x plus 3. LCD is just their product because there is no other factor. Now to get an x plus 3 in the first term, you multiply divide by x plus 3 and multiply divide by, this should be x minus 3 here. And this should be x minus 3. So you end up with x plus x minus 3, which becomes 2x minus 3 over x minus 3. Subtraction. Well, subtraction, nothing changes except you want to be careful with the distribution of this negative. When you distribute this negative, you get a negative, and then a positive, and then a negative because it's a positive, negative, and a positive. So they flip to become negative, positive, and negative. Okay, that's it for this video. Yeah.